All right, let's talk about properties of tangents of a circle. Now, if we remember from the last video, parts of a circle that I set up, we talked about some tangents. Well, a tangent is a line, such as this one that I'm drawing, that touches that circle at exactly one point. Okay, it is a line, so it does need arrows, but it touches the circle at exactly one point, and that is it. These are different from secants, chords, radius, and diameter. Okay, tangent is another thing. So again, it's a line that touches the circle at exactly one point. So let's talk about properties of tangents. So if I have a tangent, ignore the bottom two lines for a second. If I have a tangent, let's say I have this purple line here. So I fix it, there we go. Again, my tangent has those two arrows. Okay, if I have a tangent and then I also have a radius, radius we know is half of a diameter, or it goes from the center to the edge. If I have a radius and a tangent, so this blue and yellow line, they are always, always, always perpendicular. Well, if you remember back from a while ago, perpendicular just means that they form a right angle or a 90-degree angle. Okay, well, we can use this, some properties like this, to solve for some problems. So if I have a radius, that blue line, and a tangent, that yellow line, let's say I have another line going like this. Well, I don't know what that line is. But if I look closely, this shape here is actually a right triangle. And we're familiar with some right triangles. Okay, we've done some work with some right triangles. We know a property about a right triangle. If we remember the Pythagorean theorem, we have a squared plus b squared equals c squared. Okay, so let's say I had my radius to be 3 as a length. Let's say I had this second part of my tangent, this part here. Let's say that was 4. Okay, well, I want to find the length of this line here. Let's call that x. That's what I want to solve. Well, because I know properties of a right triangle and I can use Pythagorean theorem, let's plug it in. My a and my b of my Pythagorean theorem are always the legs. That's what we call them. My c is always, always, always my hypotenuse. In this case, my two legs are 3 and 4, so a and b, it does not matter which one you label as a or b. Either one doesn't matter. In this case, my hypotenuse, or my c, is x. Well, let's plug it in. I have 3 squared plus 4 squared equals x squared. Well, I want to solve for x by itself. Well, we got to simplify. So let's do 9 plus 16 equals x squared. 9 plus 16 gives me 25. So I have 25 equals x squared. Okay, well, to get rid of that x squared, or the square part, I want a square root. So I can square root both sides. I get x to be 5. So in this case, this part actually equals 5. That's how we solve some parts of a triangle. Okay, or parts of a triangle using properties of tangents. All right, that's one way to use properties of a tangent. All right, I'm going to erase all this stuff. We're going to get to what these two lines on the bottom are. So these two lines, again, are tangents. They do touch the circle at one point. There's one there, and then there's one right there. Well, if I have two tangents, and they meet outside of the circle at one point, that point out there, then these are actually congruent. Okay, well, things we know that are congruent, well, if they're congruent, we can set them equal to each other. So, again, if I have two tangents outside of the circle, then they are congruent. So in this case, because I have those two tangents, and then they do meet outside of that circle at this point, they are congruent. So let's say this part was on the left was 2x plus 3. Let's say the part on the right was 11. Well, because I know properties of tangents of a circle, I know that because I have two tangents and they meet outside of the circle, they are congruent. I can set those two equal to each other. So I have 2x plus 3 equals 11. Again, anything that is congruent, you can set equal to each other. Okay, let's solve for my x. I can move that 3 over. I get 2x equals 8, right? I just subtracted that 3 on both sides. Again, what I do to one side, I have to do the other side. Okay, and then to get x by itself, I'm going to divide both sides by 2, and x equals 4. Now, a way to check this is I can plug this 4 right back in to that x. Let's see, do I get 11? So I have 2 times 4 plus 3, which in fact, if I do solve that, I do get 11. So my answer is correct. In this case, my answer would be 4. Okay, so we just reviewed some properties of a tangent. Remember that a radius and a tangent are always perpendicular. If they create a triangle, I can use Pythagorean theorem. Remember, my A and my B are my legs. My C is always my hypotenuse. Okay, and then another property, if I have two tangents that touch outside of the circle, again, this is the problem we just did, they are always congruent. I can set those two values equal to each other, solve for whatever I need to solve for.